So just to kind of recap, we have two equations. This is a linear equation. This is a quadratic equation. We are trying to look for an x and y value that makes this equation true and makes this equation true. If we do it graphically, in other words, if we graph both of them, the solution is the intersection. So when I graph this in your graphing calculator, I see that it crosses at x equals 0, y equals 4.5. If you plugged in this equation as a fraction, it'll say 9 over 2. Remember that 9 divided by 2 is 4.5. So just by graphing these two, now the only thing I need to remind you guys of is when we graph, we have to put like y sub 2 or y sub 1. So the first equation was not set equal to y. That's easy enough to fix. I just subtract 3x from both sides, and I get y equals negative 3x plus 4.5. I graph that. That's a linear equation. And the other one was already set equal to y. So when I plug those in the graphing calculator, I get this. Okay. So that's how I solve it graphically. But to solve it algebraically, what I'm really looking for is what is this and this? Well, if the intersection occurs where they share the same x and y value, this y value has to equal this y value. In other words, this is set equal to this. So before we had a little slip up with the computer, we were in the middle of that process. So I wrote down this expression, and this is the second expression. And I set them equal to each other. Now, the first step is to make this fraction go away. Now, you can make any fraction go away by multiplying by the denominator. So I took this whole thing and I multiplied it by 2. These two cancel, and I'm left with x minus 3 squared. Now, over here, I need to distribute the 2 through the parentheses. So 2 times negative 3x is negative 6x. And then 2 times 4.5 is actually a positive 9. Easy enough. Okay. Now this is where it gets a little tricky, and it's not always the most fun. My goal is to make it look like x equals some stuff. That means I got to get all the x's on one side and all the other stuff on the other side. But it's a quadratic. So this is not hard, but it's not easy. For quadratics, it's always best to make it look like ax squared plus bx plus c equals 0. Remember, we just learned that in our last section working with quadratics. So what I need to do is I need to get all this other stuff on the other side. So what I'm going to do is I'm going to add 6x, and I'm going to subtract 9. And remember, whatever I do on one side, I'm going to add 6x and subtract 9. And so over here, I've got my 0 is equal to x minus 3 squared plus 6x minus 9. Okay, cool. So now what I want to do is I'm going to expand this. So I'm going to figure out what x minus 3 times x minus 3 is. So x minus 3 squared is the same as x minus 3 times x minus 3. So I'm going to say x times x is x squared. Negative 3 times x is negative 3x. Negative 3 times x is negative 3x. And then negative 3 times negative 3 is a positive 9. So this becomes x squared minus 3x minus 3x plus 9. We combine like terms. X's to the first power. Those are like terms. So I get x squared minus 6x plus 9. So all of this big long expression is the same as this. So I'm gonna plug that in. I'm gonna say x squared minus 6x plus 9, and then I can't forget the other stuff, which is gonna be plus 6x minus 9. So this is still equal to 0. So now if I combine like terms, I have a negative 6x to the first power. I have a positive 6x to the first power. What happens with those when I combine them? 0, yeah, it becomes 0, right? So that equals 0. What about positive 9 and negative 9 when you combine those? They cancel out. They become 0. So all that stuff becomes x squared equals 0. Does that make sense? Now, whenever we have a square, we normally take the square root. What's the square root of 0? 0, right? Because 0 times 0, in other words, 0 squared, is equal to 0 times 0, which is equal to 0. Now, normally we do the plus or minus, but 0 is not positive nor negative, so that doesn't count. So our answer is x equals 0. By the way, duh, that's what we said. X equals 0. And if you want to find the corresponding y value, you just plug it into this first equation. Y equals negative 3 times x, but we said x would equal 0 plus 4.5. Well, guess what? That equals 4.5 because 3 times 0, or I'm sorry, negative 3 times 0 is 0. 0 plus 4.5 is 4.5. Now for this one would be y is equal to 1/2. Why did I put a 3? 1/2 times the quantity 0 minus 3 squared, which is really going to be 1/2 times the quantity negative 3 squared. What's negative 3 times negative 3? 1/2 times, oops, I'll do it again. 1/2 times 9, what's 1/2 of 9? 4.5. Does that make sense? That's a lot of work, right? Question.
I kind of got confused when we got x equals 0.
Down here?
Yeah.
Okay, what at this point, like at this point or at this point or at this point? This one here? Well, we're saying there's some number x that when you square it, it equals 0. Well, but what we do in algebra when we're solving things, we do the inverse. So when you have x squared and I want to get x by itself, right? Remember our goal is x equals some stuff. I'm going to take the square root of a square. Whenever you take the square root of a square, you're left with just the base. So over here on this side, I'm just left with x. Okay? Now, when I take the square root of 0, so let me show you on the calculator. What is 3 squared? 9. Okay? So when I say we're going to take the square root of 3 squared, whenever I take the square root of something squared, I'm left with whatever's being squared. In other words, this little symbol undoes this. So you could put a really big number in there. So I could say the square root of 1, 2, 3, 4, 5, 6, 7, 8, 9 squared. And it doesn't matter what this number is. When I take the square root of a square, I'm undoing what's being done. Okay? And so then I hit enter. Guess what? It's just going to be the base, no matter what I put in there. If I say take the square root of 313 squared, it's just going to be 313. Okay? So that's the first part. So over here, when I say I have x squared, when I take the square root of a square, it's just x. Now, to take the square root of 0, To take the square root of 0, I could just plug that in the calculator and take the square root of 0. That's just 0. But remember that 3 squared is equal to 9. So when I take the square root of 9, I'm really finding what is this base. What number times itself equals 9? 3. So when I set over here, I'm looking for a number. In other words, when I take the square root of 0, I'm looking for a number that I multiply by itself or that I square to get 0. Well, there's only one number that does that. That's 0 times 0. Okay? Does that make sense?
Yeah.
Did that help?
Yeah.
Okay, cool. Any other questions before we move on? Okay.